For the polynomial negative x cubed minus x squared plus 20x, find the following. For questions about the x-intercepts, separate answers with commas and only enter the x values, not the coordinates. So first we want the end behavior of the graph using the leading coefficient test. Now, the end behavior of the graph, all we really need to do is look at the first term, the leading term in the polynomial. So that term is x cubed. And normally the graph of x cubed looks like this, or something rather similar. But in our case, because it's a negative x cubed, it's inverted. So it just flips the graph over this way. So in terms of the end behavior, our graph is going to mimic this behavior right here, which is rising to the left and falling to the right. The x-intercepts. Now to find the x-intercepts, what we need to do is factor the polynomial and set those individual linear factors equal to 0 and solve. So if I start factoring this polynomial, I think I'll just use this space right here. I have negative x cubed minus x squared plus 20x. So in general, what we would do is graph the polynomial using our calculator, get some initial real zeros, and then try to factor those out with synthetic division. But it looks like there's a common factor here that might really help us along the way here. I can definitely factor out a negative x, and that would leave me with x squared plus x minus 20. And that quadratic looks like it will factor relatively easily. So x and x would multiply to x squared, 4 and 5 would multiply to 20, and as long as the 5 is the positive value, they'll also add to 1. So the x-intercepts are the locations of the real zeros. So the x-intercepts here are 0 itself, positive 4, and negative 5. I'm just simply taking each of the factors and setting them to 0 and solving. Next, we want the behavior of the graph at the intercepts. So let's list the intercepts where the graph crosses the x-axis. So the graph crosses the x-axis whenever we have a multiplicity 1, 0. And all of these are multiplicity 1 zeros because we didn't have any exponents on these factors. So they're all exponent of 1, which means they're all multiplicity 1. So we list each of those zeros. The x-intercepts where the graph touches the axis and turns. For that to happen, we would have to have a multiplicity of 2, but we didn't have that in any of our zeros, so therefore that does not exist. Lastly, the y-intercept. So the y-intercept is the value of the function evaluated at 0. So our function being negative x cubed, so negative 0 cubed, minus 0 squared, plus 20 times 0. Because all of these terms had a factor of x, they all end up with a factor of 0, and therefore it evaluates to 0. And all that means is the graph itself actually passes through the origin, and that's its y-intercept.